Hi, hello friends. Welcome to Unacademy and welcome to today's session and welcome to Srinivasarao Sir classes. Today we are going to discuss about IP addressing. In that IP addressing, we are going to learn the advanced mechanism called supernetting. So what is the supernetting and how it is to be performed? How to answer numerical questions on supernetting? We will discuss in the today's session. Before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform and none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. We all know that Unacademy has provided wonderful digital platform to serve the dedicated students which are done by dedicated faculty members. So my dear friends, myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects. Also had a industry experience in the back end, that is the database side and system side, with the relevant good certifications. So dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students got completed their post-graduation from IITs, NITs and central universities. You can also you can also achieve just by clearing prestigious competitive examination known as a GATE. Once you crack the GATE examination, you're eligible for PSUs and campus interviews. And many of my students settled in a topmost companies as in topmost position. And some are working in PSUs and some are working GATE mentors. You also can achieve all these things just by clearing GATE examination. To clear the GATE examination, there is a proper training and a proper guidance is required. Without a training and without guidance, you cannot able to achieve that much easily because it is a full of negative marking. So dear friends, Unacademy is offering two kinds of subscription courses, Plus and Icon. Once you become a member, you will be called as a Plus student or a premium student, where you can able to attend live classes, recorded lectures, whatnot, everything which are beneficial to clear the GATE examination. So your dream is ultimately satisfied. Your dream is our dream. Our dream is an academy. So now let us see what are the subscription prices. So 12 months and 24 months and 18 months. The current second, first, third year students can opt for this. And if you use my referral code, I can be your guide. And you can able to take all my guidance and experience. Apart from that, you're also going to get a maximized discount. And after applying my referral code, you're going to get the price like this: 12 months and 18 months and 24 months subscription. Don't forget to use my referral code, otherwise I cannot be your guide. Nowadays, I am acting as a guide to many of students. Why can't you? And the second kind of a program is Iconic Batch. So there are two subscriptions like 12 months and 24 months. You may use either of the subscription and my referral code is also eligible in this. So after applying my referral code, you're going to have the subscription prices like this. And my referral code is eligible for any kind of a course, not only for this. Use my referral code to get the admission into Unacademy. Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the admission into Unacademy. Hit the bell icon for latest notifications and updates. Dear friends, let us start our session, that is Supernetting. So last sessions we have learned about subnetting. The main concept of subnetting is nothing but segregation of your HIDs into different networks. Therefore, you can able to manage the things very well. This subnetting can be done in a class C as well as class B as well as class A. And what is the main concept? Masking of HID from zeros to ones is a concept of subnetting. But what is a supernetting? Aggregation. Subnetting belongs to segregation, and supernetting belongs to aggregation of your small class C networks. So combining small class C networks is the concept of supernetting. What is the advantage by combining several small class C networks? What is the advantage? Yes, increasing number of HIDs from a class C network is the concept of supernetting. Mostly we use supernetting concept in ISP, internet service providers, where they are going to assign public IPs. So supernetting concept we are using in a public IPs assignments. What is the concept? Taking a class C network or small HID position bits, you can able to enhance the number of HIDs is a concept of supernetting. So again I am repeating, segregation is the subnetting, aggregation is the supernetting. So masking zeros to ones of your HID position of subnet mask is the subnetting. Masking network ID from ones to zeros is the concept of supernetting. It's quite opposite. Masking zeros to ones of your HID position is a subnetting. Masking ones to zeros of your NID position is a supernetting. Okay, friends, let us see a few important definitions. The process of aggregating two or more networks to generate IP addresses for the group is known as a supernet. Right? Combining several small class C networks to create a larger network is the concept of supernetting. Supernetting is used to reduce the number of routing entries and maintains a one single entry in the routing table. So supernetting is applicable most of the cases to class C address zone. What are the advantages? It improves the flexibility of IP allotments, and it reduces the number of routing table entries because a single large network is available. But in subnetting, if you do 100 subnets, you are having 100 subnetwork entries you need to maintain. But in super network, it is not like that. It is going to maintain a single large entry which is suitable for a bigger, larger network. What are the limitations? It is applicable to two or more networks. All the networks in the supernet must be of some class. That means same class. Most of the cases we are using class C. And network IDs of the networks in the supernet must be in the sequential order. Now let me show you what is the difference between subnetting and supernetting. Then we will start the process of supernetting. Already you have learned the subnetting concept. What is the subnetting concept? If I am saying subnetting, masking HID portion, masking HID portion of subnet mask from zeros to ones. This is the concept of subnetting. Therefore, what are you going to get? A large network is split into smaller networks, right? That means hosts are segregated into different blocks or different networks, into different blocks or a different network. Okay, you need to keep it in mind this particular point. Masking HID portion of subnet mask from zeros to ones. What is the supernet? When you talk about supernet, first point is very important. Masking of NID bits. Reverse. Left hand side I am going, not right hand side. Right hand side splitting is subnetting. Left hand side splitting is supernetting. Masking of NID bits from ones to zeros. Reverse I am coming. Therefore, number of HIDs are increased. Number of HIDs are increased. Point number 3. Subnetting is a splitting concept. Supernetting is an aggregation concept. Aggregation of several small class C networks. Okay, so this is a super. So I will show you few examples. Listen. Class C default mask we all know. 255 dot 255 dot. This is your default mask. What I am doing with this, how many host IDs you can get? How many host IDs you can get from the above? The answer is your HID position consists of 8 zeros. So 2 power 8 is equal to 256 at max. You will get in that minus 2 are not used. Right? So I want to increase the host. There is a node. What is that? To increase the host IDs, borrowing bits from network path. This is the magic of your supernetting. From network path. Network part of subnet mask. So I am going to borrow. So how I borrow? We will not disturb HID part now. We will disturb NID part. Right towards to left I am going. If it is subnetting left towards to right, I will go by masking zeros to ones. But now I am going right towards to left by masking 1 towards to 0. Right? So now I will show you supernetting bit manipulation. So class C network, your mask is network and network and network and 8 host IDs. My question is, can you generate 512 HIDs from class C network? Can you generate 512 HIDs from class C network? It is impossible. With the normal, the solution is not possible. If we use a default mask. This is the point. So what to do? To make it possible, what to do? Borrow This is your third octet. This is your second octet. This is your first octet. So borrow bits from third and second octets. Okay. This is what is the meaning of supernetting. After borrowing, what will happen? 512 HIDs means, so from class C network 255 dot 255 dot 255 dot 1 2 3 4 5 6 7 8. I want to generate 512 HIDs. 512 HIDs we want to generate means dash zeros required, dash 0 bits required. So the answer is 8 zeros here. So we need 9 zeros because log base 2 of your 512 is nothing but I need 2 power 9 zeros. But how many zeros you are having? Only 8 zeros only you are having. So I need to make it into 9 zeros combination. How? So borrowing. So I am borrowing from this third octet. So let me write. After borrowing, the subnet mask is, let me do the masking now. So we are not borrowing from here. We are not borrowing from here. I am borrowing from this. We are not disturbing HID part. Please observe carefully. So I am making this to 0 and I am making this to 0. So only one bit is sufficient because 8 zeros are there with you. Just I am making what? 9 zeros combination. And now these ones are as usual, but only one I have masked to 0. And this is a common 255.255. So after borrowing, the subnet mask is I have borrowed only one bit. One bit is borrowed. So you will get how many host IDs now? 9 bits for HIDs. So when you get 9 bits for HIDs, so I can happily say my answer is number of HIDs are nothing but 2 power 9, which will give us you to 512 HIDs. Well, my dear friend, let us see one more example before entering into the supernetting masking. So if I am saying let class C mask is 255.255. Eight zeros. Now I want to generate, this is the question, to generate 2000 HIDs, dash bits to be borrowed. Dash bits to be borrowed. So our answer is log base 2 of 2000 means we want 11 bit zeros, right? Because 10 zeros means, please observe, 2 power 10 means only 1000 you will get. But I want 2000, no? So 2 power 11, 2048 roughly you will get. That means 11 zeros I need. 11 zeros means how many bits to be borrowed? So that's it, your answer. So 1 and 1 and 1. Already I have got 8 zeros with me. I have borrowed 3 bits to mask like this. This we will not disturb. This we will not disturb. This we will not disturb. That's sufficient. So now you got your HID position is expanded from 8 bits to 11 bits. So how many bits borrowed? 3 bits are to be borrowed. Okay. Now let me explain. For example, class C mask is given 255, 255, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. What is the question? What is the supernet mask? What is the supernet mask to generate 2 power 16 HIDs? This is the question. So 2 power 16 HID means how many zeros you need? 16 zeros required in subnet mask. Therefore, your new mask after borrowing how many bits you need to borrow? Already 8 bits are there with us for HID. I need to borrow 8 bits from this third octet. Therefore, after borrowing 8 bits from third octet, our new mask is a new supernet mask. Now you got supernet mask. Is the first octet we have not disturbed. Second octet we have not disturbed. Third octet becomes zeros. And the fourth octet is as usually 0 is given. So what is your new mask? Your new supernet mask is 255.255.0.0. Clear now? So this is which class mask? You understand? Now what I did, this is which class mask? After borrowing 8 bits from third octet, a new mask is 255 and 255.0.0. This is equivalent to class B mask. Right? But I am performing only from class C only. See the beauty. The class C itself can generate 2 power 16 HIDs, which is equivalent to class B. Right? One more magic we do. Again, I am taking a class C only. Class C mask is given as so 255 dot 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is your class C mask, right? It is given by default like this. This is your default mask. Now you observe, I am doing manipulation. How I am doing manipulation? I have borrowed all the bits from your octet 2, octet 3. They become zeros, right? Now I am masking on to second octet now. After masking, this becomes 0. 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 This and this and this 0. Octet 1 we don't touch as it is reserved. Now tell me, from class C, how many bits I borrowed? Dashed bits are borrowed. The answer is, this is your HID position is given. We have not borrowed. This is a default. I have borrowed 8 from this and 8 from this. So how many bits are borrowed? 16 bits are borrowed. 8 from octet 3 and 8 from octet 2. Right? Now tell me, after that, second question is, this is your question 1. Your question 2 is, dash HIDs. How many your HIDs? So 8, 8, 8. It is expanded to 2 power 24 HIDs. This is equal to which class? Class A. That means class C automatically converted to class A just by borrowing your bits from octet 3 and octet 2. Right? Now, what is the mask now? Let us write the mask. What is a new SuperNet mask? Your new SuperNet mask is, let us write 255. This is manipulated, this is manipulated, this is by default is given. Your host is enhanced. Your HID part is enhanced from 8 zeros to 16 zeros and 16 zeros to 24 zeros. Now class C becomes a class B and class C becomes class A. This is what is the meaning of supernetting, my dear friends. Okay, so the main concept of supernetting is nothing but borrowing bits from NID and make the ones to zeros, or masking your ones to zeros is the concept of what? Supernetting. Let me give you one small example. The example is, class C mask is given. Class C subnet mask is given as, observe carefully, 255 and 255 and 0.0. So he is asking, the question he is asking, is it subnetted or supernetted? Can anybody please respond? Is it subnetted or is it supernetted? First you see that your class C subnet has, class C subnet means net, net, net H. This is your default position of your class C. We have not masked anything from HID part. If you mask anything from HID part, it goes to the subnetting only. That means aggregation of your HIDs. But HID we have not masked. What did we mask? So HID we have not masked. We are masking from what? NID. It is a masking from NID. Whenever it is a masking from NID, it is the concept of what? Supernetted. It is a supernetted. Right? And my second question is, dash bits are borrowed. You can also ask a question like this, dash bits are supernetted. The answer is, how many bits you borrowed? 8 bits we borrowed. 8 bits are supernetted. Right? And another example we will take. This example is saying let class C mask. Please observe carefully. These are all 1 mark important questions. Class C mask is given as 255 dot 255 dot 255 dot 192. Is it subnetted or supernetted? So we will say class C means let us identify its positions, network, 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 H. Network parts are not manipulated. They are as it is only. That's what 255. It is not done. No manipulation here. No manipulation is here. But HID part by default is supposed to be 8 zeros. But instead of 0, it is being given as 192. That means HID part is disturbed or manipulated. Whenever HID part is manipulated, it is a concept of what? It's not a supernetted. It is a subnetted. How many bits are subnetted? 192 is nothing but double one. How many bits are subnetted? Dash bits subnetted. The answer is 2 bits are subnetted. Right? Please observe the difference between previous example and this example. Previous example, HID is not disturbed, but NID is manipulated. Therefore, it is supernetted. But in this example, HID is manipulated, NID is not manipulated. Hence, it is a subnetted. So, one more example I want to take. Let class C mask is given as 255 dot 255 dot 255 dot 0. My question is it subnetted or supernetted? Is it subnetted or supernetted? Our answer is, let us take default mask of your class C. Your class C default mask is n dot n dot n dot h, which is nothing but 255 dot 255 dot 255 dot 0 means 8 zeros are there inside. That means host ID is not manipulated, and network ID is also not manipulated. Therefore, our answer is it is not a subnetted as well as it is not a supernetted. As well as it is not a supernetted. Observe 3 different examples. First example, NID is a manipulated, host HID is a fixed, so supernetted. Next example, NID is not manipulated but HID is manipulated, it is a subnetted. But here it is, default mask is given, no NID manipulated, no HID is manipulated. Therefore, it's a not subnetted and not a supernetted. All the hosts are belongs to same single network only. Okay. Now let us see another example. How to do supernetting, how to do masking, that we will see in the next session. First, let us understand the differences between without subnetting, subnetting and supernetting. The example is, let class C mask is given as yeah. Now you all tell me. My first question is, Is it subnetted or supernetted or no action? So now you need to decide your default mask. What is your default mask? Our answer to this question is, our default mask is 255.255.255, and it's supposed to be 8 zeros. And this 8 zeros part is your HID only. We know this is N, this is N, this is N, and this is H. HID is a manipulated. When HID is a manipulated in your subnet mask, it is a subnetted. Therefore, you see that it is a subnetted. A dash bits are used for subnetting. Dash bits are subnetted. Only one bit is masked, right? Only one bit is from zeros to ones it happened. Therefore, our answer is one bit is masked. My second question is, dash hosts are available. How many host IDs are there? Our answer is rest. We are having a 7 zeros. So our answer is 7 host IDs. Therefore, number of subnets are 2 power 1 and number of HIDs are 2 power 7. Right? And minus 2 are unusable. Please understand. 1 bit is a subnetting, therefore 2 power 1 subnets. And 7 host bits are there. So 2 power minus 2 HIDs for every subnetwork. Now let us show you one more example. Let class C mask is given as, I'm training you subnetting and supernetting differences. Observe carefully. 255.255.128.0. Now you know. First question, is it subnetted or supernetted? Our answer is depends on default mask of class C. What is the default mask of class C? That is N, 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 H. Right? And given one is 255 and 255, 1280. HID is not disturbed. HID is not manipulated. What is manipulated? NID is manipulated. 1, 7 zeros. Here as it is 8 zeros. This is HID part. So when NID is manipulated, we come to know that it is a supernetted. How many bits are supernetted? 8 ones. I have manipulated 7 bits to zeros from ones. So dash bits are borrowed. Our answer is how many? 7 bits are borrowed. So number of supernet blocks. Now the question arises. Number of supernet blocks are nothing but 2 power 7. You will get 128 supernets. Right? And dash HIDs. Our answer is your HID position from here to here. It is expanded. So 8 HIDs and 7 are borrowed. Therefore 15 bits HIDs. So number of HIDs are 2 power 15 HIDs minus 2 according to this question. Now one more question we go, my dear friends. I say let class C mask. I am concentrating only on class C because class C can be migrated to class B and class C can be migrated to class C in order to generate HIDs. That's why our most focus that It's a small number of HID capability 256 maximum, but I am enhancing to 2 power 8 to 2 power 16 and 2 power 8 to 2 power 24. It's a very big network I am forming using a supernetting concept just by borrowing. Let class C mask is given 255.192.0.0. We know that first question answer, it is subnetted. Why it is subnetted? Because HIDs are manipulated. HIDs are not manipulated. Your HID is a fixed, but NID is a manipulated. NID is a manipulated from ones to zeros. Here also NID is a manipulated from ones to zeros. How many manipulated? It is a subnetted. Yes. Question number 2. Dash bits are borrowed. How many bits are borrowed? So this is the borrowing, right? So let us write into binary 255.192.0.0. So this is all ones. 255 means all ones. 192 means double 160 and all zeros. And the last part is HID. We have not disturbed it. Okay. Now dash bits are borrowed. So you have borrowed 6 bits from octet 2 and 8 bits from octet 3. Total 14 bits are borrowed. And question number 3, dash supernets you will get. So dash supernets are nothing but how many bits you borrowed? 14 bits you borrowed. So number of supernets are 2 power 14. 2 power 14 supernets. And dash HIDs. Dash HIDs. Your HIDs are enhanced now. Dash HIDs. Our answer is here 8 are there. Here 8 are there. 8 plus 8, 16. 16 plus 6, 22. 2 power 22 minus 2 HID. See the beauty of supernetting. The class C is slowly migrating to class A. Okay, my dear friends. So, 2 standard questions we learned in this session. What is that? Dash supernets is nothing but number of bits borrowed. And the second question also we learned. What is that? Dash HIDs. Number of zeros. Are in given mask. Okay. Now I will show you the class C subnetting, how you can do class C subnetting. Class C supernetting, na? Class C supernetting. First, let us start with the default mask. What is your default mask? 255, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros and 24 ones because your IP block is a 32 bits. Now I am doing 1 bit supernetting. So your NID is borrowing now. Observe carefully. So this is fixed. Now 1 bit supernetting I am doing. This one is borrowed to 0 and remaining as usual. Next I want to do 2 bit borrowing. So 2 bit borrowing is nothing but this is a common. No disturbance. But here I am making 0 and 0 and this is a common. Okay, 2 bits are borrowed. That means 2 bits are used for supernetting. Now I am doing 3-bit manipulation. So 1, 2, 3, 4, 5. So 3 zeros. Ones are manipulated to zeros. Next, I want to do 4-bit supernetting. So it is a 4 zeros, right? Next, I am doing 5-bit subnetting. This is same. This is same. 1, 2, 3. This is also same. Now you got 5 zeros. 5-bit supernetting. Next, 6 bits. Next, 7 bits. Next, 8 bits. Remaining as it is. So this is 8 zeros. This is also 8 zeros. Now tell me, so far masks. So far completely third octet is manipulated. So up to here third octet is completely manipulated. Still I can manipulate second octet, right? Let us write the masks. What is your mask? First bit is manipulated now. 255 dot 255 dot. So remaining all are ones only. 7 ones. 8 ones. It is fixed. I'm doing consecutive from right towards to left. That's the meaning of supernetting rule. Consecutive manipulation required. Don't do any random manipulation. It is going to be invalid supernetting. So 7 ones means it's a 254 dot 255. And next 6 ones means 255 dot 255 dot 252 dot 0. And next one is 255 dot 255 dot 248.0. I am converting binary to decimal. Next 255.255.240.0. Next combination 255.255.224.0. Next combination 255.255.192.0. So this is 6 bits. This is 7 bits. This is 8 bits. And this is going to be 255.255.128.0. And this is going to be 255.255.0.0. By 8-bit supernetting, by 8-bit supernetting, the complete third octet is being manipulated from ones to zeros. So this is equal to your class B mask. This is equal to class B mask, no doubt. Exactly, you're also going to have 2 power 16 HIDs. This is the beauty of class C supernetting. A small C network is a combined, is becoming class B and class A. Those many HIDs you are going to get, right? So how many HIDs? This is your default mask 255, 255, 255.0. Here only 256 HIDs. Here 512 HIDs. Here 1000 HIDs. Here 2000 HIDs. Here 4000 HIDs. Here 8000 HIDs. 8K HIDs. Here 16K HIDs. Here 32K HIDs. Here 65,000 HIDs. Right? This is a 512 HIDs. This is a 1K HIDs. This is a 2K HIDs. This is a 4K HIDs. It's a double exponential order. This is a 32K HIDs. And the last one is 65,000 HIDs. Okay. Still the story is there. We have performed only third octet. I can do on second octet also. Now let me fill the second octet now. So 9-bit subnetting I am doing. So 9-bit supernetting if you do, nine-bit supernetting, it is 255.1234567. One is borrowed. This is completely masked, and this is your HID position. This we will not disturb. This is already borrowed. Become HID position. And now I am masking this. So what is a mask here? It is a 255.255. Not 255 because 7 ones now. It is 254. 254. This is completely 0. This is completely 0. Next I want to do 10-bit supernetting. You can do maximum 16 bits only because this you cannot mask. So 255.1234560. This is 0. This is 0. So your mask is, recent mask is 252.0.0. Now 11 bits supernetting I am doing. It is 255.1234500. 0, 0. Here 2 bits are manipulated. Here 3 bits are manipulated. This becomes 255, 248.0.0. Now 12-bit supernetting I am doing. This is common. 1, 2, 3, 4, 1, 2, 3, 4. 4 zeros and these are zeros. So it is a 255 and 240.0.0. Next 13-bit supernetting I want to do. This is fixed. 1, 2, 3. 1, 2, 3, 4, 5. 5 zeros are being manipulated. So the new value is a 255.224.0.0. Next to 14-bit subnetting I want to do. 1, 2, 1, 2, 3, 4, 5, 6. So 8 zeros and these are common. So it is a 255.192.0.0. Next you have 15 bits manipulation. Only 1, 1, 2, 3, 4, 5, 6, 7 zeros. 0 and 0. So 255.128.0.0. 16-bit supernetting I want to do. This is a final combination 255, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 0, which is nothing but 8 zeros are there. So 255.0.0.0. This is equal to class A mass. Now see, by borrowing from your octet 2, by borrowing all the bits from octet 3, your class C becomes class B mask. By borrowing all the bits from class, that means octet 3 and octet 2, again I am repeating, by borrowing all the bits from octet 3 as well as octet 2, you will enter into class A subnet mask. How many HIDs I can get? your HIDs, you imagine whatever the class A mask is giving, those many HIDs it also can able to process. Because 2 power 24 HIDs are there by borrowing 8 bits from octet 2 and 8 bits from octet 3, and 8 bits are already present in the HID, so total 2 power 24 HIDs I can able to. So this is how to do manipulation, my dear friends. So according to that, you can decide how many supernets are there, how many HIDs are there. So now you are very confident. By taking any mask, you can able to say the answer whether it is a subnetted or supernetted, how many HIDs are there. So before closing the session, I will give you two examples. Tomorrow we will continue obtaining supernet ID and supernet broadcast address for a given IP and subnet mask. Don't miss tomorrow's class. I am saying let class C mask is 255 and 240.0.0. This is a valid supernetting, no doubt. It is a valid supernetting, right? Because your supernetting is supposed to be consecutive masking from right towards to left zeros. So 240, how can I write? It is a 255, 240. I already shown you 240 is nothing but 4 ones, 4 zeros in that particular octet. So 4 ones, 4 zeros, and this is 8 zeros, and this is 8 zeros. Okay. So from this I can understand it is a valid subnetting. Why? Masking is done consecutively from right towards to left, from octet 3 to octet 2, consecutive zeros, hence it is a valid supernetting. If I am saying another example over here, let class C mask is given as 255.129.0.0, right? Is it a valid supernetting? Supernetting happened, I know, because HID is a fixed and NID is a manipulated. So when NID is a manipulated, we come to know that it is supernetting only. I am asking you, is it a valid supernetting? So the answer is no. Why no? Because no consecutive masking. It's not a consecutive borrowing otherwise. Why? Let me write the decimal part of it, binary part of it. 255, 129 means 1. This is your 129. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is a perfect. Octet 3 is a perfect. Octet 4 is your HID. So octet 3 is your NID. It is a perfect, all consecutive zeros only. But here your zeros are separated by your 1. That's why this 1 is not putting you proper valid supernetting. So because of this, it is not a valid because it's not a consecutive borrowing. One is separated between these zeros and these zeros. Hence, I can say that this is invalid supernetting. So it should be consecutive zeros only. That's why I have shown you the formats. Consecutive zeros from right towards to left. One bit you supposed to do. In the previous example also, how the third octet is done. First 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. Consecutive zeros from right towards to left is required. Well friends, in the next session, we will see how to obtain the supernet blocks and supernet broadcast addresses, and what are the supernet blocks we can able to derive, and address identification in supernets we will learn in the next session. Stay tuned to Unacademy. Stay tuned to Srinivasarao Sir classes of DBMS, computer networks, operating systems, and others. We will meet in the next session. Thank you for sparing your valuable time.